Hey there, it's Mr. McTavish, and this is a quick tutorial on how to make a prototype for a ball launcher. Um, what I want to do is create a prototype that I can use multiple times and just kind of have on hand to be able to quickly adjust it. So I'm going to start with the top-down design and create a sketch and use the top plane. So I'm going to use a center point rectangle, and I'm just going to click in the middle. And the bed of our laser cutter is 24 inches and 12 inches on the side. So there we go. I accidentally clicked 14. Just correct that. Now, we are going to put a bearing in the middle, and that's where the axle's going to go. Now, um, 1.125 is the diameter of the bearing, but I'm going to add a new variable called offset, and I'm going to set it to 0.01 for now. What we're going to do is we're going to create another document where we laser cut the hole, um, so that we can check the different offset values and stuff. And just gonna go into here and set it as a number that adds easily. And I don't think that. So there's the dimension tool, 1.125 plus number sign offset. There we go. So yeah, so we'll print off a bunch and go from there. So the goal is I'm going to have an axle through there. I'm going to have a 4-inch wheel that goes along there as well. So that's going to be 4 inches. Um, and what I want to do is create a series of circles. Um, but I'm going to do it one stage at a time to figure that out. Now, the only things that are going to be important are my holes. So I have bought a bunch of G2 timing pulleys and belts. And basically, what I did is I worked through, and I noticed that I spelt that wrong, but that's okay. Just there we go. So I've worked out a bunch of different things. So if you shop on VexPro, you realize that you can drive a Falcon. You can use a G2 pulley on a Falcon. It's 16 tooth, and then on the Neo 550s and 775s, it's 12 tooth. Um, and then I modified the driven gear, and what I've got is three different dimensions. Um, and I've just picked up the center to center distances to double check them. And my idea is that I'm going to keep them just a little bit bigger than the diameter of the wheels so that I can figure them out. So let's create a mount for this. Um, so what I'm going to do is I'm going to just start with this center to center distance, and it's the farthest one. So what I'm going to do is just create a horizontal line and use the dimension tool. So that's that distance right there. And if I just pull up my electronics, so this is the Falcon motor, and motor timing pulley is Falcon. And what I want to see here so there's the 16. So my outer diameter is 0.6. So 0. I think I'll do 3/4 of an inch there. So 3/4 of an inch seems to be a good size for that. So create 0.75 inches. So there's my Falcon pulley. Um, and if I look at the Falcon, I can see the drawing and my mounting holes are on this. So they're on a 2-inch diameter mounting hole. So what I will do, and those are 1032s. So just going to create it. So that's 2 inches. And what I'm going to do is I'm going to just create so a mounting hole right there and 1032s are 13/64. So I will just use that. And same thing. What I'm going to do is I'm just going vertically. So I got 4 mounting holes. I've got a lot of different options of where I mount this. Oops, not what I wanted to do. So this is equal to that. And by using the equal constraint, if I go back and make a change, I just need to change the one that has the measurement, and then everything else will fit. So there's my Falcon mounting hole. And then the second, so that covers that one. And I'm just going to cross that out so I know I've got it 120, so 4.877. And I just realized I could probably go smaller than that because this is only half the diameter for there. Okay, so that, sorry, I'm just trying to work that out. 4.877. I've copied it. Okay, so let's just go the other side. And the reason I'm using these lines is there we go. So this hole is the 12-inch, so outer diameter 0.591, so 0.5, 0.6. Now, what I'm purposely doing is this one I'm not going to put the mounting holes in yet. I'm going to do that in an assembly. And you know what? I can do the mounting holes right now. So I need my Rev Robotics. And within here, brushless. So there's the drawing. Where's the mounting holes? So the output, there's my drawing for that. And so this is on a 25mm circle. So what I will do is create a 25mm circle. And that's the beauty, is I can just type in and the diameter of that So M3 millimeters, um, that's 3 millimeters. And so I'm just going to do 3 millimeter holes on this. So what I'll do is I'll do that vertically. And then that one is going to be vertical as well. And it's going to be equal inside to this. So there's my Neo one. And then my last motor is going to be the 775 Pro. And with the 775 Pro, there's the drawing right there. So it's a 29 millimeter bolt circle, and it's an M4. So 29 millimeter. And I'll offset these holes by going that way. And then that way, those are equal to each other. So I can mount both motors. I'll need to add the motors later to be able to work out the positioning. So the last one on my spreadsheet is this. And so in order to fit everything, what I'll do is I'll just go up. Now, this one is shorter, so maybe I'll go there. Okay, so up is not going to work, so let's just undo that. And I'll go at an angle instead. And so that one, I need my spreadsheet. There we go. Okay. So dimension tool is D. That's what I'm pressing. Whoops. And what I'm doing here is just setting the angle. So that everything's good. Okay, so there we go. This circle is going to be that same circle. I'm going to have two of these. And the equal constraint is letter E. So they're the same size. Now, here's the beauty of this, is that I'm just going to create another line. And you can see by the symbols, that line is automatically perpendicular. So that's going to be really useful because then I can set these up. So my farthest circle is going to be that one right there. And I can just pick where it's going to join. And I'm going to say that's equal. A lot of zooming in here, a lot of using that mouse, equal to that one. And then my closer one, now I'm just going to mirror that while I'm here. So the mirror, select a mirror line. There we go. So I'm just using all these tools to be able to do this really quickly and efficiently. And then this is going to be my inner one right there. And that is equal to that one right there. And same thing is that I can mirror this So it's going to mirror to that line. There we go. So now I have all of my motors. Um, and I want to get in the habit of naming things. So sketch motors, green check mark. I'm going to extrude this and it's going to be 1/4 of an inch and it's going to be the sketch motors. So I've got 1/4 inch Baltic birch plywood that I'm going to use to be able to do this. Now in assembly 1, the reason I'm doing this is I'm going to insert that and I am going to fix that in place. And I'm going to add the 775 Pro motor. Just have to wait for a second for it to load. And it's just not loading. What's going on here? There we go. So motors are right there. 775 Pro. Um, Pinion. I won't worry about the connect. The ones I buy, I like having the connect. It just saves me some time. There we go. So there's the one motor. I'm just going to copy that motor. So I'm right clicking and pasting. And I am going to fasten that motor. So pick that outer circle and fasten it like that. And I just realized I need to flip that. There we go. So what I'm looking at is here is make transparent. So do I see those lined up? And it looks like they're perfectly lined up. So that's perfect. That's exactly what I want. And I'm going to fasten this one. The order that you fasten things really matters, but that's why I fixed that, because I don't really care. I just want to make sure it's going the right direction. There we go. Now this one is not going to be in the make transparent. So what I want is I want those holes lined up with that. So this is why I used 45 degrees, because I can go into this. I can edit this. And what I can do is I can set an offset and I can rotate it. Now, if I look, I can see the X and Y axes. So I want to rotate around Z, 45 degrees. Now my holes line up, which is what I want. So there we go. Perfect. So now I'm going to go back, right click, edit this part in context. And the reason I'm editing in context is I'm going to go into that sketch and I can see those parts. So I'm going to go in here, click, click, click. And if I click use, I now have a hole for that part. And the goal is to do that for all of those. In the interest of time, I'm not going to walk through that, but the key thing is you edit in context and then you go back into your motor sketch. And because you can just see any holes there, you just need to zoom in, click them, and a little time consuming. There's feature scripts that do this as well. But I do like doing this to force me to think about where things are going. And the idea is that you need vent holes for this particular motor. So I want to carve them out with my 1/8" bit and be good to go. Okay, so I have those. So now I'm going to create my sketch, and this is going to be my mounting holes. And let's let's just have a look. Oh, I just closed. Just give me a second here. I just closed it by accident. Hate when that happens. Okay, so closed it up by accident, but here we go. So what I want to do now is figure out my mounting holes for the different things. So I'm just going to create um, a sketch. Let's just go back in here. So that's 5.428. So the 5.4 is 110 tooth belt. What I'm going to do actually is I'm just going to create a sketch on here. And I'm just going to engrave text in here so that it's easy to use my prototype later on. So dimension, I don't need that. Okay, so that's my 110 tooth belt. Um, and basically, I would then engrave that, remove that sketch. Don't need to make it very deep. The big thing is that I can engrave this so it's easy to know what belt I need for the different parts. So I do that for each of those. The other thing that I would do is go into this sketch, and I'm going to select the top here. And what I'm going to do is I'm going to use this. Oh, I don't need to use the circle. I've got the origin. Um, so, oops, going to create a circle. So my idea here is I'm going to create a circle. So this circle that's my wheel. Okay. And then what I'm going to do is add another circle. And so how big of a ball am I going to have this shoot? So let's start with the 5-inch ball. And we're going to just change the position of that because obviously okay, so if this is a 5-inch ball, what we're going to do is we are going to take our 5-inch ball and we are going to add our, oops, edit, undo. We'll just use the offset, and that is going to be 1/8 of an inch thick polycarbonate. And I should have made that a construction circle. Okay, so what I have here is I have a 5-inch ball, and I'm going to add a center point circle. So I'm going to pick 1/4 inch rods. And the idea here is, again, let's make that construction. So I'm just going to make really tiny holes so that I can engrave those holes so it's easy to drill them out. Um, they're in the right spot. That's the point. So, so I can fill that hole with black and be able to do it. So there's my idea. So I'm going to remove that sketch, and instead of blind, just put through all. So I now have that. Now, this I stupidly did not change. I want it as a construction line. So there we go. So this particular hole is the perfect distance for a 5-inch ball with the 4-inch wheel. And what I can do is I can now do a pattern. So I'm going to use a circular pattern, and I'm going to um, set the feature. So that extrude I'm going to set, and it's a circular pattern. And you can see I've got degrees. There we go. So 5 degrees against 4. Um, and it's centered. So just like that, I have those holes in there. And that my goal here is to be able to laser cut these holes, engrave the text telling me which belts go where, and then have these offset holes and stuff for different diameter things. And I can mirror those as well so that regardless of which, so I'm going to mirror that circular pattern, and the plane that I'm going to mirror is not that one. I want the right plane mirrored. There we go. So that way, regardless of which motor I can do it, I can offset it. Now, what I would do next is create another one um, just a little bit offset. So I'd set a set angle so that it's kind of partway in between, but it's just a little bit bigger. And so I have all of these holes that I can quickly and easily lock into place. And I doesn't matter which motor I'm using. So if I'm using these motors, I can set it up here, and the belt goes this way and it can shoot up here. And if I'm using this motor, it goes that way and stuff. And when I just laser engrave these so that I can just drill out the holes really quickly and easily. That's the game plan, and that's what I'm trying to do. That's my shooter prototype that I can use for all kinds of situations now.